Today I'm gonna show you how I made this hub to control my smart home. It's an open source project, so we can download all files, use it and modify whatever you want. Hi, how's it going? My name is Sebastian and in this video I'm gonna tell you about the heart of my smart home. The brain is Raspberry Pi with Home Assistant on board, but this hub is its heart, so it's pretty important, you might say. However, it's not the first heart I have installed at home. Unfortunately, the previous one had several defects and required transplantation. And here you'll find a link to our video where I talk more about it. Today is the second month since surgery and everything works perfectly. So with full responsibility I can say that the transplant was successful. And now, finally, I can share it with all of you. There's a lot to cover, so without any further delay, let's get started. The hub is central part of my electrical installation. This is where almost all cables are linked. All binary sensors like wall switches, windows, doors and presence detectors, and all receivers powered with mains such as lights, outlets and thermal actuators are joined here. This solution is very flexible and allows me, for example, to turn any light or lights with any switch. Additionally, the hub is connected to a smart system, in my case, the Home Assistant, so its capabilities increase immensely. Now I have at my disposal all the bells and whistles provided by the system itself, and I can use them to control all smart appliances in my home. I can measure the temperature with a wireless sensor, check if the windows is open or not, and turn on the heating accordingly. I can use the rain gauge to determine whether the lawn needs to be watered or not. I can also create any complicated automation I can think of. And this is, in my opinion, the essence of a smart home. Things are happening by themselves in the background. I don't even have to think about it. There's one system that integrates everything at home, and I have access to it with only one application on my smartphone. Forgive me if I'm a bit harsh, but using one app for lights, another for heating, another for cameras, yet another for vacuum cleaner and call it smart home, is a gibberish. Remote control home would be more accurate. It is cool if you want to show off to your friends, but on daily basis it annoys more than helps. And don't get me wrong, I like to show off my friends too. Turning the lights on and off with my smartphone is always impressive at house parties. But when they are gone, I want two classic wall switches to work. The most important things for me in this project are reliability, resilience and maintenance free. That's why I used cables for everything I could. As I mentioned earlier, it applies to most of electrical installation in my home and the connection of the Raspberry Pi and the hub to the local network. In the previous version, the hub was connected to the Raspberry Pi, then Raspberry Pi was connected to the router. This time, both devices are connected to it via Ethernet cable. And now you may ask, why did you use an Ethernet cable like a caveman? Why? It's 21st century, use Wi-Fi, goddammit. I'm an old-fashioned guy and I think, in terms of reliability and speed, there's nothing better than copper. As the most critical element of my smart system will be connected via cable. But of course you can use Wi-Fi. It is a second best option if you can't use cable for some reason. Although I did this project mainly for myself, I wanted to be as universal as possible, so that you can fit into your unique smart home. One of the main differences between houses is their size, or rather a number of devices to be supported. That's why I made this hub in a modular form. Each module contains 16 inputs and 16 outputs, or just one of these. The maximum number of such an input-output set is 8. It's related to MCP-3017 chip and its ability to assign unique I2C address. I wrote more about it on my website if you are interested, link in the description. To sum up, this hub can have up to 128 inputs and 0 outputs, 128 outputs and 0 inputs, or something in between. In my case, it's gonna be 64 outputs and 64 inputs. As you can see, there are two types of modules. The main module, in which there's a microcontroller and power supply segment, and an expansion module with only outputs and inputs. You can combine several of them depending on your needs. Let's solder the main module and then I'll tell you all the details. But before that, let me tell you about JLC-PCB, which is sponsor of this video. They made all of these boards for me, and as always they did a great job. Even if I would want to, I seriously have nothing to complain about. Quality, as you can see, is top-notch. If your project requires custom PCB, I think JLC-PCB should be your first choice. For a couple bucks, you can get professional boards within a few days. And on top of that, they can populate all the components for you, if you don't have time or ability. Thanks JLC-PCB. Why do most SMD components fall upside down? If that pisses you off too, I have a quick tip for you that makes my life so much easier. Okay, let's go back to the montage. Let's start with the ESP32 PoE, made by Olimex. It is the main control unit of the hub. I choose it because it's small, available, which isn't apparent these days, and it's open source. My key requirements were the Ethernet port and the native integration with Home Assistant via ESP Home, what, as I said in the previous video, is a must for me. But of course, you can use Tasmota, ESP Easy, or whatever software you want. The board can be powered over Ethernet, hence the PoE, which is a nice feature to have. If your router or switch can power other devices via Ethernet port, why not use it? It simplifies the assembly. After all, it's one less cable to connect. Additionally, this board is readily swappable, and even though I didn't expect any problems with it, I'll have a backup board programmed and ready to use if this one ever fails. Power supply. There are 3 voltage sections, and all of them may or may not be completely isolated from each other. 3.3 and 5 VDC for supplying logic, 12 VDC for controlling SSRs and low voltage home installation, for example wall switches, and mains voltage. For me, it's a 230 VAC, but it could be 120 volts if you live in the US. There are several configuration options here. Depending on your needs, the entire hub can be powered from just one mains cable connected here to 12 volts will be reduced by this switching AC-DC adapter, and then it will be lowered to 5 volts with this, not present on my board, DC-DC converter. In this option, low voltages are isolated from the mains voltage by a transformer embedded in this AC-DC adapter. However, grounds of 12 and 5 volts are common, so there's no opto-isolation here, but maybe it doesn't have to be in your case. You can also connect the mains voltage and use the AC-DC adapter to get the 12 volts, but the logic section you can supply separately. You can use an external 5 volts power supply or PoE. Now all voltage sections are completely isolated from each other. That's why I decided on this version of the hub. It'll make me sleep better. And the third option. In that case, you don't need AC-DC nor DC-DC adapter. This can be useful if you need more current in your low voltage installation than this adapter can provide. It gives 1.25 amps at 12 volts, which should be sufficient in most cases, but perhaps you have more demanding devices in your system. The router, the Raspberry Pi and the hub are connected via UPS. The smart home system will work during a blackout thanks to it. Of course, I won't be able to turn on big lights or anything power hungry, but access to all sensor, an important factor in terms of safety, and the Home Assistant itself will be still available. I have read sensor installed in the windows, so if someone opens them, I will know it no matter if there's electricity or not. Additionally, Home Assistant will be aware that the power failure has occurred, thanks to this simple circuit. It is an opto-isolator plus a few resistors and a capacitor. This way I can easily detect if the mains voltage is present. I wrote an entire article about detecting mains voltage with a microcontroller, and link as usual in the description. Inputs. Since in the previous version of the hub I use Ethernet connectors, here I'm gonna stick to the same concept. Each connector has 12 volts GND and 2-3 GPIs, general purpose inputs. Or you can use a port like this with universal spring terminals. Outputs. These are classic screw terminals you surely know, so there's no much to talk about it. However, let's take a look at their arrangement. As you know, a single module can have up to 16 outputs. I divided them into 2 parts with 8 channels each, mainly to make the module as narrow as possible. But an additional advantage is the ability to connect different power sources. I mean by this that you can protect every 8 outputs with a separate fuse. You can also power one of these segments via UPS. Thanks to this, you're gonna have 8 emergency outputs. for example to power some critical lights or heating valves during a blackout. Connector for expansion modules. It's gonna make more sense to tell you about this connector after I solder the rest of the boards. As I was saying, connector for expansion modules. The power section and the microcontroller are located on the main board, so I had to pass the supply voltage and the I2C bus to all PCBs somehow, and that's why this connector is for. Both connectors are female, which may seem odd, but I did it deliberately. Thanks to that, the connector doesn't stick out beyond the housing. Therefore, to connect them, you need such a male couplers. I2C addressing. Each device on the I2C bus must have its own unique address. That's why these pins are for. And this is absolutely critical. Without it, ESP32 won't be able to communicate with MCP23017 chips. This is a good time to test if everything is working correctly. I've prepared a test dashboard in Home Assistant with all inputs and outputs. I also made a simple tool to simulate wall switches or binary sensors. Remember, be extremely careful when working with the mains voltage. And since we are talking about it, let's test my mains detection circuits. Perfect. Of course, to perform the test I had to program the ESP32, but I know from the fact that this is the least liked part of my videos, so I'm gonna skip it. All you need to know is that you can download ESP configuration file along with the other files, and the description of it is on my website. Now, let's move to the housing. The case is compatible with the DIN rail, so it'll work with classic fuse boxes. As far as I know, it is a standard in most countries. Additionally, the height and the dimension are very similar to classic fuse, apart from the length of course. So the hub can be hidden behind the standard cover to make it look nice and neat. I tried to make it as compact as possible, and I think I managed to do so. However, there was a lot to pack inside, so I couldn't make it smaller, and that's why it has to be mounted on two adjacent rails, which I hope won't be a problem at your place. I have completely separate box just for my hub, so luckily there's absolutely no problem with the space. To simplify the possible replacement of the ESP32 module, I made this flap here. Just remove one screw and you have access to the interior. And I didn't tell you about this before, but there is also an RGB LED that will show the current state of the smart home. I haven't really thought through how it's supposed to behave yet, but with whole host of colors and different ways of flicker, I can show bazillion different things. Okay, it's final time to install this and connect all cables. But before that, I have to disassemble my old hub. During the installation of this hub 2 years ago, I made some notes, which I plan to turn into full-fledged documentation. Of course, I didn't succeed. Nevertheless, these notes will be helpful now. Each cable is marked, so I know where the other end is. Fortunately, I don't have to check it all over again. Even shitty pre-documentation like this can make life much easier. Remember, turn off the power first. Electric shock is a severe threat to your health and life. I hope the new hub will work. I really don't want to put old one back together. But before that, let me address one thing which may appear in the comments: the color of the wires. Yes, I'm aware that they don't match the standard. In Europe, all phase or live wires should be brown, black or grey, neutral should be blue, and ground wires should be green or green with a yellow stripe. In the US, colors are different, but you get the gist. In order to achieve it, I'd have to lay completely separate cable to each endpoint in the house, and that would significantly increase the number of the cables in my system, which isn't small anyway. So if 2 or more endpoints were close together, I use just one cable with more wires inside, and that's why not all colors are correct. Of course, I put all of this in the documentation so that any random electrician knows how to deal with it, just in case, if something happens to me and I won't be able to tell him that in person, which I hope won't happen anytime soon. Okay, let's power it up. First the UPS to power the logic. And now the main power switch to supply everything else. The last step will be to make a cover to hide all these cables, and I'm gonna use white plexiglass for that. All I need to do is take measurements, make a drawing, cut it, drill it, mount it, and voila! And again, before you're gonna be like, why don't you use the original cover for this like you said you would? It would be much easier and less time consuming. Why? Because I forgot to try it on before the assembly, and now it doesn't fit. Anyway. Okay, the hardware is ready, and I'm very pleased how it came out. The cover isn't perfect, but it's good enough. Judge for yourself. Now it's time to integrate it with Home Assistant, but I'm gonna do it in the following video. This one is way too long already, and if you are still watching this, I'd like to thank you from the bottom of my heart. The video about Home Assistant you're gonna find here, if it's ready. If not, there will be something else.